Okay, hello everyone. So decided to start another stream. Today we'll be trying to solve the day 15 of Advent of Code 2023. I managed to solve the first part already, but it's kind of nothing to solve there. So we'll see what do we get in the part two. So let's try to read and understand. So this will be like live coding. I didn't solve the problem. I don't know what exactly the task will be for part two. I read it, skimmed a bit through it, but it's a bit cumbersome to understand. So we'll need to dig in deeper and probably use the whiteboard and trying to understand more details of what's expected from us. We'll check firstly the quality of the stream. Hopefully everything will be good. Let me check using my mobile phone. Yeah, looks like I'm online. Quality, I see it. So we can try to read a bit. Hopefully I'll keep it like that and see if there are any like comments, messages, and be able to react right away. We'll see if anyone will join or not. To try to solve it together. Okay, so checking OBS. This part is good. So what's the day 15 about? Probably you can read more in details, but in the end it's to hash a string. So the first part it's about hashing. So you're provided an exact algorithm on how you're supposed to hash something. So you'll receive an input. So the input will be in this form, like arran equal 1 slash, yeah, got comma cm minus qp equal 3. So this will be considered like a one string, and we'll need to hash it. The hashing algorithm tells us that we'll need to pick every character, get the ASCII code of this character. Then yeah, I'll need to double check as I did it a couple of days ago, this first part. Yeah, so we'll find the current value by ASCII code, and then we'll multiply this value by 17. And the resulting value will be dividing or create a modulo of 256. So yeah, you pretty much do not have anything to do in the first part. So I'll show the code a little bit later, but more importantly, it's part number 2. Yeah, I have my answer to my puzzle. So pretty straightforward. It's just a for loop. I split by a comma. I take every character. In Rust, you'll need to do like a new size. So I take it as a binary, and you transform it. You get the ASCII code by casting it to usize. And doing all the above operations, summing it and getting back a hash value. As this will be a modulo of 256, so we can assume we'll have like a vector, an array of 256 values, potential values, and let's check what's expected from us in part 2. Okay, so you convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. Okay. The book goes on to describe a series of 256 boxes numbered from 0 through 255. The boxes are arranged in a line starting from the point where light enters the facility. The boxes have holes that allow light to pass from one box to the next, all the way down to the line. Okay, so let's we have a box and we have the light, and it passes through boxes. Okay. Inside each box, there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box is a panel that opens to allow you to insert or remove lens as necessary. Along the wall, running parallel to the boxes, is a large library containing lenses organized by focal length, ranging from 1 through 9. The reindeer also brings you a small handled label print. The book goes on to explain how to perform each step in the initialization sequence. A process is called Holiday ASCII String Helper Manual Arrangement Procedure, or HashMap for short. Oh, yeah, that's cool. So, helper manual, ASCII helper manual arrangement procedure, HashMap. Okay, pretty cool one. Each step begins with a sequence of letters that indicate the label of the lens on which the steps operate. The result of running the hash algorithm on the label indicates the correct box of that step. Okay, the label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash, a minus. If the operation character is a dash, go to the relevant box and remove the lens with the given label if it's present in the box. Okay, so we have some business logic here we need to check. So if the operation character is a dash, go to the relevant box and remove the lens with the given label if it's present in the box. Oh, this is not very clear. Yeah, let's read the. Let's go on. We'll see. Maybe we'll get more details later on. Then move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. If no lens in that box has the given label, nothing happens. Yeah, so we have boxes and we have lenses. Yeah, probably we'll need to see an example to have more ideas on what exactly we're supposed to implement. Okay, so if the operation character is an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker to mark the lens with the label given in the beginning of the step so you can find it later. There are two possible situations. If there is already a lens in the box with the same label, replace the old lens with the new lens. Remove the old lens and put the new lens in its place, not moving any other lenses in the box. If there is not already a lens in the box with the same label, and the lens to the box immediately behind any lens already in the box, don't move any of the other lenses when you do this. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. Here's the contents of every box after each step in the example. Initialization sequence above. Okay. So we will initialize. So our n box 0. So in box 0 we'll have like rn1. After cm minus box 0 rn1. After qp equal 3, this means like box 0 rn1 box 1 qp3. After cm2, box 0 will have rn1 cm2 and box 1 will be qp3. After qp minus, qp minus. Okay, so pc equal 4. So we'll put pc equal 4. ot9. So in box 3 we'll have like rn1, cm2, pc4, otn9. ab equal 5 we'll put if it's pc minus. So if it's PC minus, we'll remove the PC minus. After PC equals 6. We'll put it in box 3. And OT7 will be at first. I have no clue what's going on, to be honest. So tough to understand. Why the hell do it's supposed? I mean, structurally, this looks like a hash table. Yeah, I glimpsed through Reddit, and everyone told it's a hash table. But what exactly do we need to do? So yeah, we'll need to spend some time understanding the problem itself. Yeah, let's go slowly. I mean, I guess the difficulty in this problem is to manage to read and understand what you are supposed to do. Okay, so yeah, see, I have a viewer. That's really cool. So, hello. You can write in the chat a little bit more about yourself. How did you manage to get here? That's pretty cool. Uh, so yeah, I'm Alex, by the way. So welcome aboard. Yeah, let's check once again. What in the world do they want from us? We'll read slower and hopefully I'll understand more. But at least from first reading the question, as I can see here fast, so we have some, we put it in the box. If it's equal, we push kind of in first box. If it's a CM, we try to get it out, but we don't have anything to get out. We don't have like CM to get it out. So if you have like a QP3, question is why we put QP in box number 1 and not as a new element in here. Do we have an explanation for that? I don't think we do. But yeah, probably we'll need to read again. Yeah, let's read again what's the trouble here. So yeah, I understood. We have some light. That's like the magical part of the problem, but not giving any meat to the problem itself. Inside each box, there are several lens slots that will keep. Okay, so inside each box, there are several lens slots. So this means each box may contain multiple elements. So this is the like hash table part. It's not like a hash map only, where you map one key to one value specifically. But in our case, we'll map like one key to multiple values or a vector of values. Okay, this part I got. The slide of each box has a panel that opens to allow you to insert or remove lenses as necessary. So we have a panel that opens to insert or remove lenses. Along the wall, running parallel to the box, is a large library containing lenses organized by focal length, ranging from 1 through 9. The reindeer also brings you a small hand label printer. So what in the world is this? Label printer. Okay, so we'll check later on. I guess probably just a label printer, nothing fancy. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the holiday ASCII string helper manual arrangement procedure, or hash map for sure. Okay. Each step begins with the sequence of letters that indicate the label of the lens on which the step operates. Okay, so we have like on the containing. Okay, where is that phrase? Okay, so the side of each box is a panel that opens, allows you to insert or remove lenses as necessary. Focal length slot. There are several length slots. Okay, so a sequence of letters that indicate the label of the lens on which the step operates. The result of running the hash algorithm of the label indicates the correct box for that step. Okay, so yeah, kind of let's try to dig into our whiteboard and look there. What in the world do they want from us? Each step. Okay, so the label will immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. Okay, so let's get back here. So we have Rn will be label kind of. Equal will be the sign, and the number. What does the number do? Number indicating the focal length. Okay, so we have like the label. The hash of the label will indicate the place in the box or which box. Equal sign an operation, which we'll need to figure out and understand what's going on there. And the number, what's about the number? Do we need to put them in a sorted order? That's the idea, or what exactly it's expected from us? AB5, no, it's focal length. Yeah, but shouldn't the focal length be length? Okay, so inside each box there are several length slots that will keep. Oh my god, I think they complicated this way too much. But yeah, guys, that's the reality of advent of code. I mean, you just need to spend time understanding what exactly you are supposed to do first. So try to understand the problem itself before coding it. Yeah, so we have this. The label will be followed by a character. So once again, let's look at this. So focal length organized by focal length, ranging from 1 through 9. Along the wall, running parallel to the box, is a large library containing lenses organized by focal length, ranging from 1 to 9. The reindeer also brings you a small-handed manual. Okay, so that's the box number. Yeah, let's move on. What do we have else? Each step begins with a sequence of letters that indicates the label of the lens on which the step operates. Label of the lens. Okay, so each label will be mapped into a box, if I understand correctly. The result of running the hash algorithm on the label indicates the correct box for that step. Okay, so we have like a label part. Hashing of the label part will give us the hash sign where we can find our other information. So as well, it will keep the label. So in the box, we'll keep the label. The label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. If the operation character is a dash, go to the relevant box and remove the lens with the given label. If it is present in the box, if it's present in the box, then move any remaining lenses as far forward in the box as they can go without changing their order. Okay, we remove, and then move any remaining lenses as far forward in the box as they can without changing their order, filling any space made by removing the indicated lens. Okay, if no lens in that box has given label, nothing happens. So for me to understand, so we remove an item from a box. Remaining lenses as far forward in the box. So do we need to move them backwards? Or this part I didn't get. Move any remaining lenses as far forward in the box as they can without. So we kind of need to fill in that place, that remaining place, if I understand correctly. Oh, okay. So filling any space made by removing the indicated lens has the given label. Nothing happens. Okay. So more or less, minus will just remove, and then we'll need to rearrange the labels. If the operation character is equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Okay, so it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker to mark the lens with the label given in the beginning of the step so you can find it later. There are two possible situations. Okay, I didn't get this part. So if it's equal sign, it will be followed by a number indicating the focal length. So each box will have like focal length from 1 to 9. That's the idea. Along the wall running parallel to the boxes is a large library containing lenses organized by focal length, ranging from 1 through 9. This I don't get it. So where exactly do we need to? It will be followed if the operation. Okay, it will be followed by focal length. Okay, of the lens that needs to go into the relevant box. So by label, we'll find the box. Then inside that box, we'll have multiple. So number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker. Okay, so let's see more details. It's not clear. If there is already a lens in the box with the same label, replace the old lens with the new lens. Remove the old lens and put the new lens in its place, not moving any other lenses in the box. If there is not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. Okay, so we'll chain. Don't move any other lenses when you do this. If there aren't any lenses in the box, the new lenses goes all the way to the front of the box. Okay, what? Don't move any. If there aren't any lenses in the box, the new lenses go all the way to the front of the box. Yeah, that's logical, kind of. Here is the contents of every box after each step in the example initialization sequence above. Rn1. So Rn. I assume the hash of Rn will be box 0. So we have Rn1. Here is the content. So yeah, we put Rn1 in the front of the box. We go after we do cm minus. We don't have cm in our box. So I assume the label of cm will be as well 0. So what happens if we don't have anything? If no lens in that box is the given label, nothing happens. Okay, that's clear. After we have like qp equal 3. I assume the hash of qp will be 3. Will be 1 and the value will be 3. We don't have anything in box 1, then qp will be the first item. cm. Okay, so we got like cm. I assume the label of the cm will be 2. Then we'll have equal sign. What happens if we have equal and something existing? It will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Okay, if there is already a lens in the box with the same label, replace old lens. No, we don't have. If there is not already a lens in the box, add the lens to the box immediately behind any lenses already in the box. Yeah, that's logical. So we'll add it, we'll push the item in existing array. Yeah, let's move on. We've got QP minus. We found like QP at this stage, so we'll need to remove it. This means that we'll remove the item. Nothing, will not need to do any other operations at this level. So yeah, stage is correct. So remaining only box 0, PC4. So I assume PC, hash of PC will give us the value 3. Nothing in this box. So this is the first item we'll add. OT9, probably the same hash will be here. So OT9. So it's a new one we'll add. AB5, new one we'll add. PC minus, we removed PC and we move everything on top. So PC6, we added PC at that level. OT7, here, okay, so OT exists, so we need to change OT with a new value. Oh my god, so complex, but yeah, literally it's a hash table. So literally nothing here. It's one hash table we'll need to implement. Okay. So what's our options? Probably we can create a vec of vex and use the IDs. Maybe that will be the way to go. So yeah, let's start coding and see where we'll get. So yeah, let's go back to our coding board. Yeah, I'll show a little bit the first part. So we have our solution, we have our hashing function. So this will be like the hashing part, hashing function. Part 1 will get our input. We'll split, map, sum, okay, the result. In part 2, oh yeah, we kind of forgot what's expected from us. So we do all this operation, and what's the benefit, or what do they want from us? Okay, so we managed to understand what's needed from us. Then let's see. All 256 boxes already present are always present. Only the boxes that contains any lenses are shown here within each box. Lenses are listed from front to back. Each lens is shown as its label, and focal length is square brackets. What? Yeah, let's check. To confirm that all the lenses are installed correctly, add up the focusing power of all the lenses. The focusing power of the single lens, it's the result of multiplying together. So okay, so we have like an operation. So what's the operation? So we go like a box 0 rn1, yeah, box 0 rn1, box 0 multiplied by 1, first slot, multiplied by focal length 1. Then we have like cm, box 0, second slot. Oh, so this will be the index of the slot. Multiplied by focal length 2. OT will be like first slot in the box, multiplied by focal length. So second slot, focal length. So number of the slot and the focal length. And we have some numbers. So the above example ends up with a total focusing power of 145. With the help of an over-enthusiastic reindeer in a hard hat, follow the initialization sequence. What's the focusing power of the resulting lens configuration? So this is what we need to do. So I guess let's try to come up with an algorithm, code it, refine it, and get a solution. That's the goal. Okay, getting here. So we have like part one, the hashing function. I guess we'll keep it. We'll need it. This is the structure. So that will be the result of part one and the result of part two. It's expected from us to be 145. So we have like part two. So yeah, part two will be a little bit different because we'll need a little bit different structure. First, we have like we need to pass it a little bit differently, but maybe we can create like a data structure to operate it a little bit easier. I don't know. What can we do? What stuff can we choose? So yeah, let's start like prototyping first, and then we'll see where we'll get. So we get our input. We split as in previous example by comma. Then yeah, probably the easiest way will be to map the result. So we'll have like our string and then do here the operation. We'll need to split again by operator, but not by operator. We'll need to do some capturing. We'll need to do some capturing maybe. Yeah, I guess we have something in this form. So we have like a rn1. We need to get all the parts. So we have rn1. What will be the easiest way to split it? Because some of them have equal sign, others they don't. So I guess one way to do it nothing fancy comes to my mind, but we can try something like that. We know that we'll have a digit part. Yeah, probably using a regex. Yeah, let's try to do a regex. So let's add our regexing part. Add regex. Added the regex part. Here, yeah, I don't think it's very smart to do it at this level every time to unwrap it. Let regex will be like regex new, and then we'll provide a pattern. When I play with regexes, every time I do, I use a tool. So let me show you that part. So we'll use the browser, but before that, let me get to this URL. So it's regex 101. I think that's called. So browser, show the browser. So we'll have like a regex 101. And here you can play around and, for example, use Rust. So you can check the results of your regexes. So it's a very handy, useful tool to play and see what you can do with your regexes. So we have structures like this: AB equal 1, we have CM minus, GP equal 3. So we need to capture, I guess we'll start first by any letter. This could be written in this form, plus. So this will capture the first part. So we can see we have the following matches like AB, AB, CM, GP, GP. We even can do it specifically like 2, but I'm not sure. Probably we should check my input. Let me check the input of the file. Do we have different ones? Yeah, looks like we have 3 and 4 of them. Yeah, even 5. So it's not a good structure. So we shouldn't expect them to be only 2. So here it's not only 2, it's multiple. So we'll keep it like this because we may have like a b, that will be as well a thing. Okay, so we have this. Then we have some options. We'll need to capture the sign. We'll need to capture this sign. So sign in our case will be one of the two. So it will be either a minus or an equal. So this will be the sign part. And we may have or may not have the last digit plus. Could be one or multiple of those. So I guess that will be the pattern. And we have like 3 groups. But this pattern doesn't catch CM minus because it's expected to have a string. So instead of this, we can use not plus. Plus means we need at least to have one or many. But star sign, it's allowing us to have none. So as you can see here, we have all of our groups captured. So here we have like group 1, 2, 3. So this captures our structure. Like group 1 will be the string. We have the sign and the value. So we have another match. But in our case, and for this one, the group 3, it's an empty string. So we'll ignore if the sign is minus. Yeah, everything looks correct. So yeah, we copy this, copy to clipboard, and go back to our code part, and let's paste our regex. Oh, so this will be our regex, and we'll need to unwrap it. Yeah, and kind of will need to cargo install this cargo run. What's the trouble? Invalid suffix gm. Yeah, we don't probably need it, but I assume we need to provide something. So gm means G will be global and M multi-lines, but in our case, none of them exist because it's just a single line. So yeah, let's include this. Oh, hi guys, I see a little bit more people joining. So that's good news. So we have our regex. Now we kind of need to match our regex. So let groups, probably you can call it. And we have a regex match, or not match, but capture. So let's try this capture, and this will be our S. And I have no clue what will happen. So we have multiple captures. If you have multiple capture, yeah, let's read a little bit of on what's the ending result. Unwrap, extract. So we can do it like this. So we have like one group, second group, then this could be like oh, okay, this will be the full, and then we'll have like group title and group yeah. So in our case, we will have something like this, and wrap, and then extract, and then we'll have like a full. I actually don't think I need full in this case, but inside we'll have label, then we'll have sign or operation. Yeah, let's call it operation, and we have maybe string. I guess we can call it like maybe maybe. Okay, so let's call focal power. How do they call it? Let me check. How do they call it in? It's focal power, I guess they call it. Focal length. No, not focal length. No, or focal length. Yeah, focal length, call it. Wherever. Yeah, that's good for us. So we have focal length. Yeah, I'm not fully trusting this structure, so probably we'll do a small print and see what in the world we are getting. So let's print line this. Bam, 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 bam. So we'll have like label, operation, and focal length. And let's return something. So yeah, most likely we'll need to do something like this: label, operation, length as tuples, focal length. So this will be our structure, data structure, and we can collect them for now. But later on we can do other operations. So let result. Let me collect them for now as a back of tuples. So yeah, probably I can do it here to be easier. So let's print it. And we'll do like result. We don't need full. We can use underscore to ignore this part. So let's run our test for now and see what we'll get. So we've got the following: rn equal 1, cm minus, and here we got like empty string. I'm not sure I like this. So probably our structure, our lens. Hello, can you see the chats? Yeah, I do. Sorry, maybe with a bit of delay, but I see the chats. Yeah, I'm pretty sure you left already, but I see it with delay, unfortunately. But if you are here, yeah, for now I see it. So we are there, but we kind of don't need this, and this may create less troubles, or maybe not. Maybe we can use as will this create trouble for us? I'm thinking if yes or not. Anyway, we'll need to pass the string, but they may be or they may be not existing. So focal length will be either an empty string if it's the case, or could be some value. So maybe we should do some structure, something like this, type like a box. I don't know. No, box, it's already used. Oh, good, good. How are you? I hope you ain't disturbing you. Oh, sure not. I mean, good that there is some people. I just try to solve some problem and as well improve my speaking skills, explanation skills, and so on. So advent of code, it's a very nice way on how I can do it. So usually I work with TypeScript, Node.js at my current job, but I heavily invested lately in Rust, so plan to. Where are you from? Oh, I'm from Moldova, Republic of Moldova. So it's a neighbor of Ukraine and Romania. So it's a small country in Eastern Europe. Okay, so let's first thing which we'll need to do, I guess, is we'll need to pass this focal length. So let's try like let focal length, focal length will be this, and we'll pass it. What's the timing? I think it's like 10:05 or 22:06. 1:30 in the morning. Oh, you probably need to go to sleep, bro. That's definitely not a good routine. But we, yeah, geeks usually they spend the nights working. But that's when you're young, you can do it for a long time. But with years, yeah, okay, study for exams. Oh, yeah, I think like it's the first half of the year probably. I have an exam on codes. Yeah. Uh, to be honest, it takes a lot of time to learn and it's becoming good at coding. So don't worry about it. Just start slowly, and you'll get up little by little. You'll learn a thing, two. Okay, so let me unwrap or, and here I'll put none. But yeah, actually it will not allow me to put none. Maybe zero. Okay, whatever. Let's put zero, so to not waste time. Because we'll still will not use it. It's a minus. We'll remove it. The C language. Any tips? Yeah, I recall C language. It's like 13 years ago when I started. We used to write C. I mean, I guess in university, at university, most of the time we'll spend at first like running different algorithms, data structures. So it's not specifically dependent on the language. Yeah, C, it's a good language to start. Like you'll have the same for loops, same structs. Um, it's a very fast language. I'm laying the linked list. Linked list. Yeah, that's a common data structure. Very useful. Where you have like uh, you have like a first node, where like usually in Rust it's very complex to make it. So probably it will be a bad idea to UK a lot. So yeah, but linked list in essence you'll have like a node, you'll have a value, and you'll have a next, which will be a pointer to another node. So I guess I don't recall exactly what will be the syntax for this in C, but usually you'll have like the value for the node, and then the next part will be a reference or a pointer to the next node. So you'll keep the address of this. Yeah, yeah. So this will be a linked list. You could have like a double linked list where we have like next and prev part. So this will be like a double linked list. Yeah, I mean, linked lists, it's a useful data structure, but it's not super useful in practice when you become like a professional programming. Um, uh, it's very dependent on the cases. So one case where you'll need you will not be able to do anything without a linked list is when you have like huge inputs and you go with streams where, for example, you chunk stuff and you consume stuff. So you'll not know at runtime what will be the size of your inputs. Because, for example, in a vector, which is similar to a linked list, and most of the time we use a vector instead of a linked list. Oh, what's like to work as a software engineer? It's there are advantages, but things to do? Like, do they just give you things? It's different. I mean, when you start as a junior, very likely you'll be put into a project. You'll have assignments like to understand the code, write some unit tests, understand what exactly uh, how exactly the things work, so you'll not have like any big important tasks. Once you get to a mid level, you'll be given like features to develop. You'll write a lot of unit tests. You participate in creation of architectures of the systems. When you're a senior, then you're supposed to teach others, like to teach juniors. Um, yeah, participate as well into developing or development of the architectures and stuff. So it's still coding as a senior, but you'll have more role of a coach and a teacher as well. Uh, this is the part of the senior. But as a start, you'll just learn the things. You'll learn to code. You'll learn how to. You'll have some tasks for sure. Because if you'll not be productive, no one will keep you. Because at the end of the day, if you don't bring money, what's the point? Okay, so we did this. Let's run again and see the new structure. Yeah, so at least for now, we have either 0 here or our focal length. So do we have all of our components for our hash map? Yeah, so I think we do. Everything is paused. We put 0 here, but doesn't matter because we'll remove the item. I think we have everything we need to move on. So we have our tuple. I guess further on, we'll need to fold everything into our hash table. But our hash table, we know it's, we can think of it as a vector. Let me think it's if it will be a fast structure if it's a vector. Yeah, probably you can start. But what will be the structure, the data structure? So yeah, let's think first on the data structure. So type a hash map. Maybe we can call it hash map or whatever. So it will be a vector for sure. And inside this vector will be something in the form of like label and focal length. What can we call this? Label focal length. Maybe lens. Okay, whatever. Let's call it lens. Len. I don't know. That's a singular of len. Okay, bye. Wish you good luck to your exam, bro. So it's an interesting profession for sure, but it's a lot of time you'll need to spend training. It's like a sport, to be honest. I'm in the business for 13 years already, and still I'm far from being satisfied and knowing everything. So always improving. So good luck. Nice for you to visit. So yeah, we'll have our land structure, and the land structure will contain like an str. Yeah, that will be our part, and a new size. We're not on new size. Let's be an I32. Cause let me think. Oh yeah, cool. So let me think. So will we need anything else? We do not store the operator, so we store only label and the value. Okay, so I think this will just work. Okay. I guess it's too many of those. Yeah, they will want me to provide a lifetime. Yeah, let's keep it simple for now. I don't want to spend like 2 hours trying to understand lifetimes and explaining them. So I'll just mark it as a string for now. Okay, so we have our hash map. So let's create it. Hash map. We know that our hash map will be a fixed size. So probably we can create as a vect here. Maybe we can initialize it as a vec inside and give like 255 of those from 0, yeah, 0 to 255. So here, yeah, it will not allow us to be like this. It's not a hash map, but I guess it will be a hash table. And we'll need to create it mutable, and we'll need to provide our structure. So it will be like vec of len. So now it's allow us. So this will be our hash table. Oh, I'm back from my bed. I decided I want to become a guy who will hack Wi-Fi's and stuff. How how can I be one? Oh, that's actually a funny story because when I started, when I was like 15 years old or something like that, I also wanted to be a hacker. So uh, the funny part is, in order to become a hacker, you'll need to start understanding how computers work. So you'll need to dig into networks. Yeah, you are 16. Yeah, make sure you will not do the same mistake as I did. So I kind of got into learning a lot, like learning how computers work, like how networks work, how memory works, how to create viruses and stuff. But sooner or later, you'll get into programming. So you'll need to start coding, like to write code, to learn a language. And I remember I started with PHP. This is like a scripting language. And I wanted to write a port scanner to scan for ports. And I started digging on how to do it. Yeah, now it's way easier because there are a billion of tutorials. At that time, uh, there was less information, so you needed to like literally finding it into books. You need to read books. So I find some scripts, and I didn't get anything on how do they work. And I got deeper and deeper into PHP on what this stuff does, and then after a couple of years, I suddenly understood that I forgot my goal. My goal was to become a hacker, but I became a programmer. So, so yeah, yeah. With the hacking part, I don't know. I would not advise you to go this path. Um, as a software engineer, you'll be very well paid, um, and you'll never need to like trick someone or steal something to go on the dark side. Like tricking, stealing. Maybe you think that that's cool, but actually that's not cool at all. Hacking. There is a like a compartment of hacking. It's called like hackers, or uh, they they also called like a security penetration engineers, where they you pay for a company to hack you to show you all your vulnerabilities. So this kind of hackers, it's fine, it's legal, it's allowed. But like stealing, manipulating, all this dark side, this will not bring you happiness for sure in the long run, and you may be like put to jail, and it's a bad advice. Ethical hacking, exactly, ethical hacking. So ethical hacking, it's one thing, but like hacking for profit, because you'll be into carding, like stealing credit cards. You'll be into a lot of social engineering hacking, where you'll phone like someone from Europe, and not only Europe, but some old people, and trick them that they get some problems, and you'll steal their money and stuff. I don't know. I mean, to spend your time doing this, yeah, probably you'll have some money, but deep inside you'll feel like you waste your time, energy, and focus. So becoming a software engineer, it's tough for sure. It's tougher than stealing from someone, but at least you'll be a happy person in the end. You'll be productive. You'll be useful for society. And why not? If you'll do a big project, a huge project, you may get a lot of recognition and money and stuff. So yeah, becoming a hacker, maybe it's like a cool thing, but don't advise it if you don't want to be an ethical hacker. Okay, so kind of, yeah, I have my hash table. Yeah, we'll need to implement our logic now. So do we need to provide this hash table as an input? Yeah, maybe we'll provide as an input. So yeah, probably we can fold it. And we will provide our hash table as input. And we'll have our accumulator and our item. How much a coffee cost? Me not trying to change subject. How much a coffee cost? Me not trying to. How much a coffee cost? In my country, you mean? Yeah, so it's around two. So what will be the currency of reference? If it's dollars, I think it's like it depends on the quality, but you can get up to $1.50 to $5. $5, like really expensive coffee. But starting at $1, I don't think we can find anything. Probably can call it coffee technically, but it will not be coffee there. Less than $1.50. Yeah, yeah, that's cool. I mean, Moldova, this country, it's as well not the richest. I think we are called the poorest country in Europe. So that's the reference. So yeah, a lot of growth here needed. Teas? Yeah, for sure we do. I mean, we import a lot. We have like Chinese, like green stuff from Thailand, Indian stuff. I don't recall much. Chai? I think we do. Some sorts. We have like specialized tea shops where we can find everything you want. But it's not particularly popular. I mean, wine. Uh, the vast majority of people here they drink wine. So, so yeah, yeah. Looks like this problem I'll spend some time to to solve. But at least it's not difficult. So that's the good thing. Okay, so we got our item. Let's unfold everything. So we have like focal length. So we have like a label, operation, and focal length. Focal length. We get it from the item. And we need to return the accumulator next. We don't need that. Here will be result. So probably, yeah, probably we'll do it like this. It'll be a little bit cleaner. Yeah, so we got our hash table. So first thing we need to put items in the hash table, and then we'll see. Yeah, I mean it's not necessarily difficult. This one, it's not like complex in the sense of, or in comparison to the previous days of advent of code. This one is pretty straightforward. So I'll check, maybe there will be like performance issues, but at least for now, I didn't see like a lot of troubles. I just need to do some pretty easy operations. So I'll need to find the index, and we'll have like hash of the label. So this will be our index, and this will give us the box part. Oh, at least it's funny. I mean, I do this stream for someone, so I can be useful by giving you some answer to your questions. Maybe I can guide you. So maybe in many years you'll remember me, that I did you an advice. So let's say I am accumulating like a good karma. Yeah, so we have our index. Yeah, let's see. Labels, maybe. Let's see what do we get in our accumulator of index hash. Yeah, let's change that to becoming a new size. So we've got a vec of string and i32s of labels. So we got our structure. You're not be a bad hacker. Yeah, I mean, it's not like one very important concept which I understood and I suggest you to understand. Like hackers are not, let's say, I mean the bad ones, are not necessarily like very smart. Yeah, you need to be like smart, but a smart person will never go this path. A smart person will push a little bit more, and he'll become like a good software engineer. It doesn't need to. Can you use ChatGPT here? Yeah, I can, but specifically for the sake of solving the problems, I do not use the ChatGPT part. So I can enable this. So there is a thing called Copilot, which most of the engineers use. So it will give me the solution. So he will understand what I need to do, and very likely he'll give me he will generate the code for me. Yeah, maybe I'll need to write a little bit more, because he doesn't understand what my algorithm is. It's supposed to do at this moment. But it's possible. So yeah, let's try and see. This is called like Copilot, because it's a helper. It helps me to be more productive. But for the sake of advent of code, it's not like it's not useful. So you can imagine it like this. So when you work, you'll have like a lot of redundant, maybe like boring tasks, where routine tasks, where this can be automated most of the time, and Copilot helps you. But at the same time, in order to improve, you'll need to make your brain like a focus, and you'll need to train yourself. So I treat like this problem solving more like a training ground. I call it a dojo. So you think of it as like karate or taekwondo, where you do drills. Yeah. So programming in this form is just training me the algorithmics. So when I train, I don't use Copilot, but at work I use it. Okay, it helped me to be more productive. I do things way faster, and and it's assisted. I wouldn't tell that it will do your job, but assist me for many things. So for example, if I want to do things like a print here, it will understand that I want to print labels or something, and it will generate code for me. Sometimes if I tell like explain me what this code does, so yeah, so I can ask Copilot explain this, and it will start explaining what this code do. So it's pretty useful. So for example, it tries to do this Rust code is part of the function in part 2 that takes a string reference as an input and returns a result with an I64 value. Then we do this regex part. Next, a mutable variable hash table. So it gives like an explanation on what this code do. So it's helpful. It's not a silver bullet, but it's helpful for sure. But let's close it because I want to solve this problem without Copilot. At least I do it for all advent of code. I just want to write myself the code. Later on, I may use it to optimize it or improve it or give me like faster, better solutions. But for now, this is a training exercise. So just want to train. Okay, so go sleep, bro. Okay, so I guess I'll get back to the coding part. Yeah, sure. Yeah, welcome. Uh, Nice to meet you too. Okay, so let's get back to the problem. I kind of forgot what exactly did I wanted to do. So yeah, we've got our labels. Then I guess we need to match for operation. Let's match for the operation part. So we have like two possibilities, either equal, and we'll do this, or we don't have any other option than minus. But this will be treated as the minus part, and remove the label from the hash table. And this one has removed the label from the hash table. Okay, so we'll be removing fill the empty space. Fill the empty space. Okay, so here we'll have like if, okay, so push the new label to the end if there is none. Yeah, I'm thinking maybe we can do it a little bit differently though. Because if you go like this vector of string, maybe I can map it, but I will need to keep the order. Yeah, the trouble is in the order part. Okay, so push the new label to the end of if there is none, or replace the existing label with the new focal length. So yeah, let's try to code this part. Fill the empty space. So we have our labels. Then if I guess remove the new focal length, push the new label to the end if there is none. Okay, so replace. I guess the simplest way to do that will be like labels is empty. If labels is empty, then we'll do like labels push, and we'll create our tuple. and this will be like label label to string, and label vocal length. So this will be this part, and replace the existing label with the new focal length. If it's not empty, then we'll find the item, maybe. So let's call it existing label, maybe existing label, or maybe label, and we will try to find it in the labels. So this will be like iterator, and let's find. And here it will be like X. So it will be what we are supposed to find, and we are supposed to find, yeah, probably I'll extract something like label part here. No, it will be like difficult. Yeah, let me call it L and F. Actually, I don't need F at all. So I have this, and we try to find like L equal label. And this will return as an option. Yeah, but probably we'll need the index as well. Okay, so let's enumerate. And here we'll have like index and label, more like this. Yeah, okay, so maybe label, it's not this value. Okay, so this will be option of use size. Okay, so if it's option, then we'll have the index, so we'll be able to replace with the new value. Okay, so if we have this option, then what else can we do? So we can do the following. So we'll do if, I guess, found label. If if we found our label, okay, let's use the structure. Maybe label. So if we found it, then I guess not only that, but index and found label. Yes, that will be more like it. So if we found it, then we need to replace. So we need to write the code for this part. Okay, so this is the found label. Do we need actually the found label? I don't think we need it at all. We need just the index. Okay, so we just need the index. And then we'll do like labels of index. Yeah, we'll need to do these labels mutable. Label of index will be like the new label to string and focal length. So this will be the tuple. So okay, what's the parts we needed to do, and we did. We have this. Yeah, probably this I can put it here and remove this line. It's a little bit uglier this way, but I don't mind it for now. So we added if it's empty and we replaced if it's existing. So we did this part. How fast it is, it's not clear yet. Okay, so we have the second part, remove the label from the hash table, fill the empty space. So keep so I guess the trouble here it's we have yeah, probably in Rust there is some helper functions to do that. But first thing which we'll need to do is like we'll need to find our maybe label. So if let, I guess same part as above. We will not need anything special, but labels again, enumerate, iterator, enumerate, and we'll have like find x, and we'll have like x. It's not like clear, but it's more like we don't need this part, we need this, and we don't need that part. What's the problem? I think I need to close this somewhere. I actually don't need to do this here. I think I need to do it like that. Okay. What do we need to write here? Okay, so yeah, same stuff, label. So we need to find it. So yeah, we've got our index. Then probably the easiest way on how we can do that is to use a partition. Can we use a partition? Maybe partition point. I can do like labels, iterator, partition, but not partition. I need partition point. Or I guess I can do two of them. Maybe I can do like I'm thinking on trying something like the following lines, because we need to get rid of it. I guess the simplest way to get rid of an item with okay, let's dig a little bit on the internet and see what Rust remove item from back reorder. So if we want to, okay, so we have like a retain. Oh my god, 1 3. That's so cool. So there is a retain method. Okay, guys, so that's a cool thing. So there is a retain method in Rust. Kind of retain. And what will be retaining? Yeah, let's check a little bit on the description how exactly this stuff works. So okay, so let's assume we have some example. Retains only the elements specified the predicate. In other words, remove all elements E for which f of E returns false. This method operates in place, visiting each element exactly once in the original order and preserve the order of the retained elements. So exactly what we want to do. So we have like our vector, but it's a vector of tuples. And then we retain x divided by 2. We don't need that. We need to retain everything which is not our label. Okay, so we will retain. Yeah, here I guess we'll need the other parts as well. So L and focal point. So we'll be retaining. So X will be our item. Yeah, probably here I'll do like as well local L, and I don't need this. How can I use better naming? Maybe label to find. Yeah, sorry about that, guys. Yeah, I have like a lot of labels here. I just need to think of some better names. But anyway, so let it be X, wherever. So we'll do like this L. It's not equal. Retain everything which is not equal with our X. So is this mutating? Let me see. Okay, so assert vec retain, so it mutates the original vector. Okay, that's cool. So it mutates the original vector. So we have this part. I think we're done actually. If it doesn't exist, we will not get here. So I think we're done. Yeah, oh, wait, actually we're not done yet. So yeah, remove the label from the hash. Retain the initial order. Retaining the initial order. Okay, so we have our accumulator, but now our label changed. So our label structure did change. So yeah, we can collapse this part to have it clearer. So we have our fold, and I guess we need to yeah, here we kind of, when you use this structure, we kind of move it, I think. So we don't get a reference. Maybe a better way to do it will be like get and unwrap, and then we'll get the reference struct. So if you do it, we'll not need to push it back, because if you specify like the index, we move it. We do a clone actually. So we'll need to replace it back. So probably this will be like a better way to do it. Okay, so we have our fold part. I would like to see what my hash table or yeah, I guess we don't need this. And we don't need this as well. Yeah, we'll clean up it a little bit later. Yeah, we don't need this. Wait, what's the trouble? Variable doesn't need to be mutable. Okay, why? Cannot borrow labels as mutable as behind the reference. Labels is a reference, so the data is a reference cannot be borrowed. Consider specifying the binding type as mutable vec. But I want it to be mutable. What's the trouble? Yeah, kind of. But how can I get a mutable? Maybe we need to do it like. Okay, maybe we do it like mute back of string of I32. Maybe like that we specify. And here we create it like mute. Then it doesn't like this part, found reference. Okay. Yeah, so there are two things here. We'll optimize it later, but for now, let's keep it simple. Because yeah, Rust is notorious for losing half day trying to optimize things, which not necessarily consider borrowing here. Oh, so okay. weird stuff, but anyway, it should work. So yeah, we cloned it and then we'll put it back. We'll replace here at this stage. So yeah, we have this immutable borrow occurs here. Cannot borrow labels as mutable because it's also borrowed as immutable. Where? Oh my god. That's sad, but yeah, what can we do? Let's do it. Yeah. Rabbit hole of borrowings and mutability in Rust. So yeah, I just want some things to just be done, and that's it for now. Okay, so we have this part, and then we'll need like our accumulator.index. We'll need to change the value to labels. So yeah, this needs to be mutable. That's agree. And then we have our hash table. So we've got our hash table. Would be nice to see it. So let's print it. It's a little bit less than what I've expected. Yeah, let's get back to the day 15 and see the last structure. After OT7. No, I don't think it worked as expected. Yeah, probably need to debug it. Yeah, let's do it a little bit differently, probably. Yeah, we got some items, that's good. But example, so yeah, this is the input. So it looks like it didn't work. Yeah, I guess time for debugging. What can we tell? Time for debugging. Put a couple of breakpoints and try to understand what's up. So let's give it a shot. We have debug port. We start our debugger. We got our index. What's the index number? So index is 0. We look into accumulator of index 0. What do we have? So it's empty, I assume. Yeah, we push. First item. Wait, this we don't need to do. We need to do an else here. Okay, so this is the first bug. So, because either it's 0 or we replace. Because if we do that again and again, we'll never finish. So if it's empty or not. So first bug found. Yeah, let's run again. Yeah, we don't need this. Let's run this again. If it's empty, we push. And we have like our labels, rn1. So far, so good. We have our accumulator, and so far, so good. We move again. Next one will be, item will be like CM minus. Okay, index of CM minus will be 0. Find. I didn't found anything. Move on. Okay, so it's rn1 still. That's correct. Move on. What's this one? It's index 1. Okay, so this will be like box 1. Fortunately, I cannot see it anymore. So it's empty, we push. Index of 1, accumulator. It doesn't show much, but now I guess we can see it. So it will be like QP3. Seems legit so far. Okay, so I'll just leave it to finish for now. It looks like we've got like our good structure. Actually not. So still something, it's not right. Yeah, let's continue our debugging. Somewhere we just destroy everything. Yeah, probably would be nice to have as a reference. Let me put on the right side as a reference what's our expected stuff. So let me copy this. And I'll have like a special, let me put in a special file, and this I'll move to the right. And here we have like a box 0 rn1 after cm box 0 rn1 after qp3. We need to have like rn1 and qp3. So let's see what's our troubles. Okay, so we have this. At this stage, our accumulator is empty. Yeah, I think I overdid it a little bit. Yeah, let's put here. So accumulator is Rn1. And let's be a little bit more specific. I just want to watch what's the label. CM. So after CM, I guess an operation. Yeah, let me add operation as well. Operation minus. After CM minus, the structure we expect to be Rn1. So after this, it's still Rn1. Yeah, let's move on. We don't need this. After QP equal 3, the structure expected to be box 0 Rn1, box 1 QP3. Okay, we are good at this level. Yeah, let's see after CM what's going on. Rn1, but we don't have like CM2. So we have a bug. It's expected to have like a CM2 somewhere here. Oh, okay. Okay. So if it's not empty, I think I got it. So if it's not empty, then we need to find it. But if we didn't find it, we'll still need to push it to the end. So else we'll push it. So I guess these two are redundant. So probably I'll just leave the first one. Because it doesn't make any sense to have. Because either we have it and then we'll need to do the replacement, or we don't have it and we'll always just push. Because even if it's first or last, it doesn't matter. We just need to push it. So yeah, let me close and I'll give it another shot. Yeah, that's not a good idea. I just needed to test for now this stuff. No, not this, please. Go here. Okay, so we've got a little bit different structure. Let's compare. So after OTE7, we have Rn1 in box 0 and CM2. Okay, that's good. Box 1, 2, and 3. So in box 3, we have OT7, AB5, and PC6. And everything else, it's empty. So I guess we are good. We are good with this stuff. Our hash table works as expected. Time to finish our problem and compute the end result. So how can we do that? We got our fold So we got our hash table, and actually this doesn't need to be immutable. That's correct. Now we'll need to compute the end result, and we will do some fancy chainings. So we'll do something like that. Result. And then we'll have our hash table. We'll need to go create an iterator. After we do the iterator, we need to filter not empty ones, like item is empty. I guess like that. Is empty. I guess item is not empty. We'll be filtering all the ones which are not empty. Then we'll map, and we'll receive our vector of string of i32s. This vector will create another iterator. We'll enumerate the iterator because we need, if I understood correctly, we will need to map the index multiplied by the focal length. So then we'll enumerate this, and this will be like a sum. So we'll need to fold them. The initial value will be a 0 because this will be like okay, so we'll have our accumulator, we'll have not accumulator, we'll have our index, our ID, wherever, and then we'll have another tuple. If I am not mistaken, we will have our accumulator and item. Okay, let's do it like that. I think it will be easier. And here, yeah, this becomes quite complex very fast. Okay, so what's the trouble? Closure is expected to take 2 arguments. Okay, so what's the problem? but it takes a single 2-tuple argument. Wait. So we have this. So we will have accumulator and item. Okay, now it's clear. So instead of item, we will need to destructure this. We don't need the labels, but we need the value. So we'll need the value. Let's call the value just v. No, this will be like index. And we'll have another tuple. We don't need the first value, but we'll need a value of i32. Okay, so this is what we need. And now we'll need to, for this accumulator, we need to sum index plus 1, because we start at 0, and multiply it by value, but we'll need to dereference it because it's an i32. Sum it, and then return the accumulator. And this needs to be immutable. Okay, so this looks a little bit ugly, for sure. Okay, so what don't you like here? It's much closer. What? Okay, so I think somewhere yeah, we kind of need to close this. Here, I'll need to do it like that. Val, I guess I'll need to accumulate as an I64. So this I'll need to cast as I64. Okay. Yeah, that will be like more like it. And in the end, we'll need to sum everything. That's an I32. Let's end with this, and we'll return its result. But we expect an I64. Oh my god. Okay, so yeah, let's try to do an I60 I32 wherever. Let's code. Yeah, we didn't use this. We just used the land part. And now, if we run our test, we see that we've got like 40, but we expected it to be 145. So looks like it didn't work. Okay, so then we should have a bug somewhere. And let's check, I guess, again, what's expected from us. Maybe we didn't understand correctly the problem. So yeah, let's check here. So we've got the result. So bug 0, I ran 1. Bug 0, first slot multiplied by focal length, it's 1. CM, second slot multiplied by focal length, it's 4. Box 3, first slot, 7. 1 multiplied by... Oh, wait a second. We need to keep in consideration as well the box number, I assume. So 3 multiplied wait, I don't understand the thing. So okay, so what's this? 1 what's the formula here? Focal length. Okay, so focal length, it's clear. So PC box 4. So box index will be, so we have like box 1. What's 1? Box 0. And what's 4? Oh, okay, so box 0 will mean like it's first. Oh, okay, so we need to multiply as well with the index of the box. Okay, that's not a trouble. Not very complex. I think we can figure it out pretty fast in the code and add this as well. So we need to not only do this, I guess we'll not be able to filter them anymore. So this will disappear. Okay, we need to keep the order. So we'll need to enumerate. Then we'll have like a box index. We'll need to keep the box index as well. And we'll need to use the box index in our multiplication. So box index plus 1. Because we need to multiply it by 1. But this will be like as well as I32. So yeah, this is more like it. Okay, so our tests are good. Cargo test. Let's do cargo run. The len is 2555, but the index is 255. Wait a second, I think I messed up a little bit with the number. I guess that's the back, as we don't start, we have 256. But the index will be 255. Okay, so that should be more like it. Cargo run. So we received our value. We've received our value. Let's try to put this value inside the solution. Submit it. That's the right answer. You're 1 gold star closer to restoring snail operations. So good. Yeah, looks like we finished this part. It was a pretty straightforward one, nothing fancy here. I guess we can try to optimize it a little bit, because the timing of 11 milliseconds for the result, I feel like it's a little bit, I don't know, too much. You know, maybe we can optimize it a little bit and make it faster. And how can we do that? Because you see the results for part one, we've got like 300 microseconds. But for part two, we've got like 11 milliseconds. So here we'll need to think of ways on how we can make it faster. So I guess these operations are time consuming. We need to find the index of the we need to find the index in the vector. So in order to get rid of this structure, probably we can try to use something different. I don't know. We kind of still need to keep the order, but because we are searching. Okay, so let's keep it simple. We are searching by label. So in order to get rid of this, we have like a data structure for that, like a hash map. So instead of like keeping everything into a vec of strings in this form, we can keep it as a hash map in the form of, so for each box, we'll have like a hash map of, let's put it like a string, yeah, rm, and inside we may keep like order and focal length. Because the trouble with the hash map, it doesn't keep the order of insertion, so we may have it in a very weird different order. So even if we found it fast, if insert one new, we'll need to keep of like what's the highest order and maintain it. Add +1, -1, because when we remove stuff, yeah, I'm thinking how can we do it faster? Because this order maintenance, after we do an operation like an insert, we add a new box. We kind of will need to keep the order. So how can we do that? I don't know. Maybe extend our vec to contain something in the form of. I don't know. It's tricky. That will be like the easiest way to do it for now. Yeah, for now I don't know. Because even if you do the hash map, yeah, we'll get rid of this, the defined part. So if we compute like complexity of the algorithm, where do we spend the most of our time? So this stuff, it's all for one pretty much. We have the index of the accumulator, so we get the labels right away. Yeah, we spend tons of memory on cloning this, so that's not very optimal. That's for sure. That's another trouble. Because we need like to get a mutable reference somewhere and try to to mutate it. Maybe take. Is it like take? And trying to find a way on how I can get rid of this cloning part. Not take, it's take. Whoa, forgot the way. Accumulator get index. So index, this works quite interestingly, because this returns, returns a reference to an element of subslives depending on the type of the index. If a given position returns a reference to element at that position or none, if out of bounds. Sub-slice corresponding to that range or none. Okay. How can I get it mutable? Maybe get mute. There is something like that. Oh, there is get mute. Oh, okay, so we have something similar. So yeah, let's optimize it first by reducing this clone size and all this weird problems which we have. So for now, let me comment this part. And I'll be trying to get it first. So get mute. And then I'll provide the index. And we'll try to unwrap. Because we sure this index exists. I mean, yeah, it would be nice to write it in a better way in the form of... but let's assume everything is good. So we don't need now to clone it. So looks like this simple trick avoided us to do the clone part. So this is the old run. If you do like a new run, yeah, that's this stuff is not needed anymore, hopefully. Cargo test. Yeah, so all tests are good. Cargo run. You see, we got like 2 seconds less. 1 second less. So this like a cloning things, this reduce, so yeah, probably need to run it a couple more times. Yeah, literally a 1 millisecond improvement. So just reading a little bit of documentation in Rust gives you this cool possibility to optimize 1 millisecond. Okay. Yeah, so we don't need this line. I feel like the code looks pretty straightforward, easy. I don't think I have anything. Yeah, I feel like this part maybe we need to cloning it. Wait, why do we need to clone this? Let me think again. Because we have a mutable reference. And we find it. We find it. Yeah, let me think. Why do we need this to be cloned? So actually we're cloning the reference, so this doesn't make any sense. Yeah, so this is cheap anyway. Yeah, this sometime like a Rust. Rust is a weird language, to be honest. I don't get it, guys. Why this needs to be cloned? Because yeah, if you remove the clone part, yeah, and I think there is a faster way. Maybe there is a find pause, find position or something. I feel like I should find map. Do they have like a find position? Find map. Yeah, I guess for now we'll do this trick with enumerate. I don't see like a find pause. Yeah, I mean, yeah, let's keep it. Anyway, it's a reference, so even if you do clone, but here, actually we clone all values. But yeah, but we do the change in our... Yeah, let me think. This is pretty weird. I cannot get it. So yeah, if we have like let's assume we have like labels, and we get from 0 to like labels of len. So we get this range. String of 532. Okay. And now we use this instead. We don't need to clone it. This doesn't do anything. What's the trouble? I don't know what compile time. The trace size is not implemented for string. Okay, our local variables have a static. Consider borrowing here. You want this? Okay. So if we borrow, then okay, labels is mutable because it's also borrowed as immutable. My God, you're so tricky. So yeah, looks like we need to clone it. What can we do? In order to find the needed label, but wait, why do we need to find it? What I'm trying to find? Why do I find and then change? Because this doesn't make any sense. I mean, if it's there, then retain. But what happens if we do like this? So we don't need it at all. So we just have the label upwards. So we just find and then retain, and that's weird resource consumption. Cargo run. Oh, so another millisecond. We are slowly getting there, guys. Yeah. Slowly but surely we are getting there. Okay. What else can we improve? I mean, on the main algorithm. Labels of IDX, maybe this part. No, kind of we need to see if it's there or not. Yeah, probably we need to see if it's there or not. I guess we can try to implement find on our own. But that will be the same algorithm, so I don't think it's some huge improvement. No, okay, let's keep it for now. It's good enough. 9.63 milliseconds for this huge data input. I'm good. I feel like we should be fine. It's not like half an hour or seconds, milliseconds, just wherever. Okay, so let's commit this. Looks like I have weird stuff here, which I'll need to RAM this. Yeah. So we remove this, git status, and now git add, git commit, added the source code. Okay, so added the solution for day 15, advent of code. Let's push it. I think I'll provide a link in not a link, but probably a link to the solution on the description of the YouTube stream. And I think we're good for today. Yeah, we spent a couple of hours. Yeah, for sure, this problem could have been solved way faster and easier, but we had someone on the stream, and he was asking questions, and I was answering them. So, yeah, have a nice evening, guys. I think we are good for today. Bye bye.